Have you ever wondered what makes two shapes congruent in geometry? It's a question that puzzles many, but fret not. The answer is simpler than you may think. Congruency in geometry refers to an exact match in both shape and size. Imagine two identical twins. They might have different names or be in different places, but their physical attributes are precisely the same. That's the essence of congruency. Now, in the world of geometry, we have specific rules to establish this congruency. There are three primary rules that we'll be exploring together: the side-side-side, abbreviated as SSS, the angle-side-angle or ASA, and finally the angle-angle side, known as AAS. Each of these rules provides a unique perspective on how to determine congruency, offering a new way to look at shapes and their relationships. So without further ado, now let's dive deeper into each of these rules. So, what exactly does side-side-side or SSS mean in terms of congruency? Well, let's dive right into it. In the realm of geometry, congruency is a key concept that helps us understand the relationships between shapes, especially triangles. When we talk about side-side-side or SS congruency, we're referring to a specific rule that applies to triangles. This rule tells us that if the three sides of one triangle are equal to the three sides of another triangle, then the two triangles are congruent. Imagine two triangles, triangle A and triangle B. Triangle A has sides of lengths A, B, and C, and triangle B has sides of lengths X, Y, and Z. According to the SS rule, if A equals X, B equals Y, and C equals Z, then triangle A is congruent to triangle B. This means that they're essentially the same shape and size, even if they're positioned differently or flipped around. Now, it's important to remember that the order of the sides matters. The sides that you're comparing need to correspond to each other. So you can't just say that because all the sides of two triangles are equal, they're congruent. The longest side of one triangle needs to be equal to the longest side of the other, the shortest to the shortest, and the middle to the middle. But why is this rule so important? Well, it's because it gives us a quick and easy way to determine if two triangles are congruent without having to measure all the angles. It's a tool, a shortcut if you will, that mathematicians use to solve complex problems and understand the world around us. And there you have it. That's the SSS rule in a nutshell. It's a fundamental principle in geometry that bridges the gap between abstract concepts and tangible reality. It's a testament to the wonder of mathematics and how it helps us make sense of the world. So that's the SS rule. Simple, right? But wait till you hear about the next one. Next up is the angle-side-angle or ASA rule. Sounds interesting, doesn't it? Let's dive right in. Picture two triangles in your mind. Now imagine that two angles and the included side of one triangle are exactly the same as two angles and the included side of the other triangle. What does this tell us? It tells us that these two triangles are congruent. This, my friends, is the essence of the angle-side-angle or ASA rule. Let's break this down further. The term included side is important here. It refers to the side that is between the two angles we are considering. So, in the ASA rule, we're looking at two angles and the side that lies between them. If these three elements in one triangle are equal to the corresponding elements in another triangle, we can confidently declare the two triangles as congruent. But why does this rule work? Well, it all comes down to the inherent properties of triangles. Remember, a triangle has three angles and the sum of these angles is always 180 degrees. So if two angles of a triangle are equal to two angles of another triangle, the third angle in both triangles must also be equal. And if the included side is also equal, then it's a done deal. The two triangles are congruent. Let's consider an example. Imagine a triangle with angles of 30 and 60 degrees, and the side between these angles measures 5 units. Now let's say we have another triangle with the same angles and the included side length. According to the ASA rule, these two triangles are congruent. Now, isn't that fascinating? The ASA rule is a powerful tool in geometry, and it helps us understand and compare different shapes with ease. It's like having a secret decoder ring for triangles. And that's the ASA rule for you, but we're not done yet. Finally, we have the angle-angle side or AAS rule. Ready to explore it? The AAS rule is another important concept in the study of congruent triangles. This rule states that if two angles and a non-included side of one triangle are equal to two angles and a non-included side of another triangle, then the two triangles are congruent. Let's break that down a bit. Consider two triangles, triangle ABC and triangle DEF. If angle A equals angle D and angle B equals angle E and side BC equals side EF, then triangle ABC is congruent to triangle DF. Now remember, the side we're comparing here is not included between the two angles we're considering. That's why we say it's a non-included side. You might be wondering why it matters whether the side is included or not. Well, the order of the elements in the rule name actually gives us a clue. In the AAS rule, the side comes last, indicating that it's not nestled between the two angles. This is different from the ASA rule, where the side comes in between the two angles. These small details can make a big difference in geometry. Let's look at an example to make this clearer. Imagine you have two triangles. In the first triangle, the angles measure 50 and 60 degrees, and the side opposite the 50-degree angle measures 5 units. In the second triangle, the angles also measure 50 and 60 degrees, and the side opposite the 50-degree angle also measures 5 units. According to the AAS rule, these two triangles are congruent because they have two equal angles and a corresponding equal non-included side. So, next time you're examining triangles, remember to consider the AAS rule. It might just help you determine whether the triangles you're looking at are congruent or not. And that wraps up our exploration of the AAS rule and indeed all the congruency rules in geometry. So, we've learned quite a bit today, haven't we? We've delved into the side-side-side congruency, where triangles are congruent if all their sides are equal. We've also unraveled the angle-side-angle rule and the angle-angle-side rule of congruency. Each of these rules, unique yet interconnected, are powerful tools for solving many geometric conundrums. Remember, practice makes perfect, so keep exploring, keep practicing, and you'll master these rules in no time. Until next time, happy learning!